show by the principle of mathematical induction that for all n belonging to the set of natural numbers, the following is true. So here we do not have to prove the following. Our goal will be to show that it is a true statement for any natural number that we pick up. Okay, let us begin. So what we'll do, first we're going to consider a statement and we're going to denote it by P of n. So let P of n be the statement such that we have cosine of alpha multiplied to cosine of 2 alpha multiplied to cosine of 4 alpha. So this is going to continue all the way up to cosine of 2 raised to the power of n minus 1 times alpha, and this is given by sine of 2 raised to the power of n times alpha divided by 2 raised to the power of n multiplied to sine alpha. Fine. So this is a statement. We're going to label this as statement number 1. Our goal will be to show that this is a true statement for all natural numbers, for all values of n belonging to the set of natural numbers. That means any natural number that we pick up, this statement has to be a true statement. So to do this, what we'll do, first we're going to verify if it is true for n equals to 1 or not. So for n equals to 1, when we check out, we'll get a statement P of 1 such that we'll only consider the first term, which is cosine of alpha, or what we can do, we can consider the nth term, cosine of 2 raised to the power of n minus 1 times alpha. So if we substitute n with 1, that's simply going to give us cosine of alpha. So this is going to be equals to sine of, so here we have 2 raised to the power of 1, so that's simply 2 alpha. So we have sine of 2 alpha divided by 2 times sine alpha. Fine. Now sine of 2 alpha, we can expand this using the half angle formula. We know that the half angle formula that's given by, if we have sine of 2 theta, so this is simply going to be equals to 2 times sine of half of angle 2 theta, so that's going to be theta, multiplied to cosine of half of the angle 2 theta, so that's going to give us theta. So that means we have 2 times sine of, since we have 2 alpha, so our half of 2 alpha will be simply alpha, multiplied to cosine of 2 alpha over 2, so that's alpha, divided by the denominator, which is 2 times sine alpha. So this is going to be cosine of alpha. So here, what we have shown here is that the statement P of 1, this is a true statement. So statement P of 1 is true. Now, if P of 1 is true, so we'll have to prove that it is true for other natural numbers as well. So here what we'll do, we're going to consider that let P of m, let's say this is a true statement. So let P of m be a true statement. So what does it mean? If P of m is true, this simply implies that P of m such that we have cosine of alpha multiplied to cosine of 2 alpha multiplied to cosine of 4 alpha. So this goes on to cosine of 2 raised to the power of, now in place of n minus 1, we're going to replace the n value with m such that we get 2 raised to the power of m minus 1 times alpha. This is going to be equals to, so in the numerator we have sine of the angle 2 raised to the power of m alpha divided by 2 raised to the power of m times sine of alpha. So we're saying that this is a true statement. So let's label this as statement number 2. Now using this statement, our goal will be to show that P of m plus 1 is true. So to verify, this is what we need to do. We need to verify that P of m plus 1, so this is also true. This is also a true statement. Now, what is P of m plus 1? So let's try to understand this. P of m plus 1 is simply going to be given by, we have cosine of alpha times cosine of 2 alpha times cosine of 4 alpha going all the way up to cosine of 2 raised to the power of m minus 1 times alpha. But what we'll do, we will have to consider one more term. If we replace m with m plus 1, so we're going to get the last term, which is cosine of 2 raised to the power of m times alpha. So we have to show that this is going to be equals to sine of the angle 2 raised to the power of m plus 1 times alpha divided by 2 raised to the power of m plus 1 multiplied to sine alpha. So this is going to be our task. We'll have to show, let's call it statement number 3. We have to verify that this is also a true statement. So how shall we do that? So we are going to take the help of statement number 2, and we'll start from the left hand side. So now let us start from the left hand side of the statement p of m plus 1. So what is the left hand side? So let's write it down. We have cosine of alpha multiplied to cosine of 2 alpha times cosine of 4 alpha multiplied all the way up to cosine of 2 raised to the power of m minus 1 alpha multiplied to cosine of 2 raised to the power of m alpha. Fine. Now here what we can do, we can consider the first term and consider all the way up to the second last term. Now this is simply the right hand side of statement number 2. We can replace this with this expression because 2 is already a true statement. So this is going to be equals to sine of 2 raised to the power of m times alpha whole divided by 2 raised to the power of m multiplied to sine alpha. This is going to get multiplied to the last term, which is cosine of 2 raised to the power of m times alpha. Fine. Now what we'll do, we are going to multiply both numerator and the denominator with the factor 2. Now this is done because now what we have is 2 times sine of some angle multiplied to cosine of the same angle. So here we can apply the half angle formula. So this means in the numerator we will simply have sine of 2 times the angle of sine and cosine, which is 2 raised to the power of m multiplied to alpha divided by, now 2 multiplied to 2 raised to the power of m using the law of exponents, that's going to be 2 raised to the power of m plus 1 multiplied to sine alpha, which means that this is going to be equals to sine of 2 raised to the power of m plus 1 times alpha divided by 2 raised to the power of m plus 1 multiplied to sine alpha, and we see that this is exactly the expression on the right hand side of statement number 3. So we started out from the left hand side and we were able to show this is the and this exactly equals to the right hand side. So that means we have, this implies that the left hand side of our expression that's equals to the right hand side, and when both of them are equal, so this tells us that the statement that we considered p of m plus 1, so that is a true statement. So this means that we started out by considering the statement p of m. We say that we assume that p of m is true, and we were able to show that p of m plus 1, that is also a true statement. So this is also a true statement. So now we can finally generalize this statement. That means we can say that by using the principle of mathematical induction, we were able to show that the original statement, which is denoted by p of n, so p of n is going to be a true statement, and it is going to be true for all values of n belonging to the set of natural numbers. That means any natural number that we pick up, the original statement given by p of n, that is always going to be a true statement. So we have successfully proved our problem.